10:15 now, so maybe I should start. Okay, so welcome to the advanced database course. Let me share the screen here for the actual Cambro site. We're talking about Cambro, so here it is. So I assume everybody can see this. Just answer in the chat if you can't, I guess. So yeah, so this is the main site for the course, and yeah, I'd like to just make sure that at one point you can get to this thing. So I want to verify that everybody can reach this. All right. Let's just quickly go through what the dynamics of the course are. And again, any questions you have, just put it in the chat, and I'll keep an eye on the chat. This is, first of all, this is the Zoom ID, and presumably we'll keep this ID the whole term. Okay, so during the course meeting times, this will always be open, and then of course it'll be used for any kind of one-on-one meetings or group meetings that we have. So these are the times. So if you go to time edit here, these are the times that the courses that we're going to be holding lecture. 10 to 12 here. So that's today. And then if you just go through this here, you'll see them all. Okay. So I trust everybody can see that. Let's see here. How do I do a quick poll here of everybody? So how many people had took the first database course, DV202, with me? Did maybe answer in the chat just to say yes, you did, or yes, okay, yes, yes, yes. No, okay. There's some no's. All right. Okay, so yeah, you're a little. Okay, very good. Okay, so at least looks like a large number have taken that course, so that's good. So that's kind of just a kind of a poll I just wanted to see. All right. But of course, the ones that didn't answer yes, I assume you have an equivalent kind of initial relational database course, because this class assumes knowledge of basic relational databases plus semi-structured. We'll allude to that. But let's get into the actual mechanics of this course. All right, so this will give you some insights into the techniques that underpin modern database systems as well as their application. What's going to be covered in the course are the data structures and algorithms that support efficient data access. So kind of like the internals of a relational engine, which includes query optimization. And then we're going to go into a fair bit into transaction processing. So by the end of this course, you're going to be pretty expert at transaction processing in relational databases. So we're also going to talk about some other things that you hear. Pretty much it's open. Anything that kind of it relates to databases that are out there being used is kind of open in this course. So I kind of want to introduce you to just kind of the whole range of different techniques, so that if you actually work in the field, that you then wind up having kind of a good at least working vocabulary to cover everything. All right. So that'll include data warehouses, and then an important thing that is going to be new this year is data extraction and data exchange. So this is very critical. I mean, this is very important. So this is happening all over the time. So there's lots of work that gets involved with this. So data extraction has to do with like getting data into a structured form or a semi-structured form from things that are what we'll call zero structures. So text files, PDFs, this kind of thing. So as you can imagine, there's a lot of work going on there in the industry. Data exchange has to do with moving data from one database to another. So if they're both relational, then it's kind of straightforward. But sometimes there's an issue of like data exchange between semi-structured into a structured database, or vice versa. The whole JSON format is going to be covered here in the data exchange as well. So that's kind of the new way of doing it, is with JSON, and there's some theoretical stuff too that'll get covered there. And then just a whole range of different technologies. So actually, at this point, if you guys, I mean, not at this point, but just in general, I'll leave that your question in a sec. Suggesting to me like anything that you want me to cover. So like for instance, I mean, how many people have heard of like WordPress? I mean, WordPress is very widely used as a content management system. So maybe people want us to kind of look into WordPress a little bit, or to, just, I'll let you guys kind of drive what you want us to cover a little bit. So I'll keep kind of the main slides, the main backbone of the course. But if people have certain technologies that they've heard of, they want to hear a little bit about, then we can all kind of jointly explore them, provided they have something to do with databases. Okay, so that's kind of what the general kind of gist of the course is. So by the end of this course, I mean, you should really be ready to go out and well, maybe you already are, but you'll even be more ready to go out and actually contribute and work, get paid for work in databases. That's kind of the point in a way. So there's so I guess there's some questions coming up about, well, it looks like that Jan and Amanda are maybe she's going to help him solve this thing. I don't really quite understand what it takes to. I mean, there's enrolled and there's registered. So I guess registered is that just means that you've been accepted into the course as a. You can potentially be in the course, but then you have to enroll. And then I guess when you enroll, then you. I mean, with me, when it comes down to it, I never ever hang up on these kind of bureaucratic things. I figure they're gonna solve themselves. So if you're worried, if I don't get enrolled by a certain date, Michael's not going to accept me as a test. No, I will. So as long as we get it cleared up by the end of the course, then you'll be fine as far as on these kind of bureaucratic points. So we'll figure it out. But it would be important for everybody to kind of get access to the Canberra site. That would be important. Okay. All right. So the course content. So basically, it's going to be a series of slides and handouts and lectures. All right. So it's going to be 9 lectures. That's going to be what we do on Zoom here. I definitely appreciate interruptions in the lecture. So I don't know how we're going to do that. I think the way we just do it is just unmute yourself and say something. Again, I like it when you do that. So, I mean, if it winds up bogging down, then of course I'll let you know, and then we'll just kind of get through the content. But I definitely would like that, or put something in the chat if you wanted me to respond. Okay, during the lecture. All right. So there's 9 lectures, and then there's 4 recitations. So recitations, I think that for the people who had me in the beginning database course, which is actually DV202. This is DV187. And the first course was DV202. So I don't know. I mean, it's a little bit strange, but that's the way. That's just the key system that they came up with. So this course builds on a course that has a higher number. So, but anyways, for those people who've taken DV202, you know how recitations work, and that is that I'll give you a set of problems, and then I'll have you. I'll kind of randomly select people to present. So when it comes to that, then I guess we're going to do a Zoom. I guess Zoom recitation on Zoom might be actually pretty efficient in a way. So at least I want to get audio, but it would be nice if we got video also, people presenting maybe. We'll think about that, about how the mechanics of that work. If you do maybe what you would want to do then, if you were going to, you could certainly, I mean, I have a marker board here. So I'll be presenting on, when I want to write something, I'll put it on the marker board. When you guys do your recitations over Zoom, yeah, I mean, you can maybe do your camera. Maybe you could also have like a screenshot where you show you show your work on the screen. So again, what recitations, the way it works is that with recitation, we hold it at a specific time, and then there's a set of problems that were handed out before that. Students do the problems, and then I will randomly call upon students to show what their work is. So, but again, the important thing about recitations, maybe I should actually show myself here talking, but you guys can hear me. The thing about recitations is that, remember again, that it's not so much that you get the problem right, but that you just give it an honest attempt, and then we generate a lot of discussion around the problem that way. All right, the recitations. I'll get into that in a second here. I just want to say the recitation rules are basically described here. But I just wanted to tell people that if you were looking at a link yesterday, maybe you might have seen the recitations from before, and that's not. We're going to do new recitations, so don't. They're not released yet. Okay, so the recitations are not released yet. But here's where they will be released when they are, And there'll be basically a database review and advanced SQL. That'll be one of the recitations, the first recitation. And then we'll have one on database tuning. And what this is about like having a fairly large database, and that that if you don't do tuning, if you don't build indexes, you don't kind of have it set up correctly, it's too slow. All right. So what database tuning will be about is you taking a database, a fairly large database, and you tuning it so that queries can be answered more efficiently over it, sub-second. So the goal is basically to get sub-second performance on the querying. So now because of that, it's going to have to be a fairly large database. If it's a smaller database, then it'll always be sub-second. So I have to kind of prepare it for you guys a fairly large database. And because of that, and because of the complications around support and them having to kind of administer all these separate database instances, I figured, no, look, they don't have to do that. Instead, what I want you guys to basically download and install PostgreSQL on your own machines and to have your own installation of a database. It's kind of important that you be able to do that anyways. And then you can tune it on that installation that you have. All right, so that's an expectation there that you can download and configure PostgreSQL on your own system. So if you want to start working on recitation type stuff, go and do that. If you're not up to that task, then I don't know if this is the right course for you, because we're assuming kind of a certain adeptness at doing this, like installing PostgreSQL shouldn't be that hard. All right. Okay. So that'll be recitation number 2. Then recitation number 3 will also be over PostgreSQL, and it'll be transactions. So this will be some experiments about running transactions. The last one will be this data extraction exchange recitation, which I haven't developed yet, but I will. All right. So that's how recitations work. Are there any questions on how recitations work? Anybody? Any questions? All right. No. By the way, I assume everybody can hear me well, or is there anything I should adjust in the environment here, the Zoom environment? Just let me know. Oh, good. Somebody, yeah, I hear a voice. Yes? Somebody? No. Oh, well. It's kind of lonely to lecture this way. I'm used to having more interaction, but that's what happens in the time of COVID. Let's see, how many do we have here? Uh-oh. Wait a sec. Uh-oh. Hey, how many people are still there? Because it looks like I just had a 0. Is everybody here? Okay.
Yeah, still here.
Yeah, I'm here.
I just got a weird, yeah, very good, very good. I just got a weird message saying there was only 1 participant. Maybe that was weird. Again, the thing is, I'm a little bit worried right now because the power went off. I don't know if I told you guys, but the power went off out here about like a half hour ago or something. And if it happens again, then I'm screwed. But I have it on my mobile phone now, so I'd call in. But anyways, that was weird. Okay, but otherwise,
question.
It looks like
a question.
Yeah.
The exam, it's not on the schedule, so I'm wondering.
Yeah, so that will be. I think those don't show up on the time edit for some silly reason. The exam will be held on, or the quiz, or the test, or what do you want to call it? It will be held on Zoom, or on Cambro. So it won't be anything you have to go to. I'll add that in. I'll send out a message telling you guys exactly when that is. That's one of my action items. I know they have a time, and you could probably find it yourself somewhere. But for some reason, it doesn't get added to time edit, at least not yet. Time for test. Okay. Are there any other questions? I guess we'll get to that in a little bit. Okay, so screen share. So, okay, so can you, that's weird. Okay, so, all right. Okay, now I guess I lost the screen share. That's strange. All right, let's go on here. Let's just get this done here. Okay, so the timing topic of the, so the timing and the topic of the lectures are going to basically be determined as we run the course. So there's not like really a set schedule for that, although it's going to kind of follow, the slides are there already, so it's going to kind of follow them in order. Let's see here. Okay. Okay, so basically the course consists of 9 lectures, 4 recitations, 1 makeup recitation. So there's a makeup time we can do recitation, which is very easy in the time of in the era of Zoom. A short exam, and a couple meetings covering student projects. Okay, so actually the best part of this course is the student projects. I think that you guys are going to agree. I think most students enjoy that projects, and I'll get to that in a second. So, so the entire course will be held on Zoom at the times in time edit, and here's the Zoom ID, and this won't change. Okay. Now projects. So the course projects are basically documented here. So you can have a maximum of 3 students in a project. So what I want with the projects is I want people to really kind of dig and figure out what it is that you really want to do. So if you have a hobby, or if you have some something that you have an idea for a startup or something, you have a startup you're already working on, you have something that you're curious about that you can formulate a project problem over. It's really on you guys to kind of come up with the idea for the project, and then I'll listen. I'll hear you out, and I'll give you some suggestions, and then we'll go through a dialogue and iteration, a negotiation, and then we'll get it approved. I have some of my own ideas about some projects, so if people are interested, but I'll just hold off on those for a little while. But I'll be kind of maybe kind of tossing out those ideas here and there. As we go on. So basically the way it works is I haven't updated the dates, unfortunately, but these are approximate. The way it works is this, is that what I want you to do is I want you to basically send this email of this form to me. So keep it really simple. I don't want any PDFs or anything. I just want straight text. And what I want is I want you basically first of all, when you guys form groups, the groups can be a maximum of 3 students in a group, and you have 1 leader. Okay, but you can also do solo projects where there's one, a group of 1, and there's 1 leader. That's the person, and that's the sole contact person for the group. So I want you then to send an email to me within exactly this following form. Basically. Here's the heading is just, or the subject line is just the course ID, and then basically it's the project proposal. And then the title of the project, and then the names of each of the members, and then an abstract of maximum of 250 words. Okay, so that's where you describe what it is you're going to be working on, what it is that you propose to do. So kind of like, to kind of keep it really tight, we'll do that. So again, right now, we have a fair amount of time to get this proposal approved. So we'll say the 24th. I guess we can just keep that as the date, the 24th. I don't know what day of week that is, but we want to get it kind of clear by then. All right. So then, if you don't get it accepted, then I will take a little bit of a meal here, 100 points, because I want to have some kind of forcing function on this. Okay, now the presentation phase. So then by October 25th, the leaders, you should send me a URL that has a 5-minute video demonstrating the project. Okay, so your presentation will be a video, 5-minute video, and then you also have to have a 4-page report that's also attached to that. Then if you were, okay, this is basically saying that when I talk about these dates here, then I'd say that it's the last place on planet Earth. I guess the Kingman Reef is way out there. If you were on the Kingman Reef, then as long as you get it in by that time, so it's actually not sometime on the 25th in Swedish time, but that's a little gives you a little bit extra time there. All right. There's a lecture note format I want you to put the reports in, so I want everything to kind of look kind of similar. All right. So to submit your projects, you must send an email. Okay, so then this is basically where you're just kind of putting in the link and attaching the report. All right, then what we're going to have is we're going to have a peer review. So each of you are going to review the projects of your fellows, all right? And you're going to give it grades, like the video, what's the style, the substance, and the overall, and the report, the style, substance, and overall, and then comments. Okay, so I say some stuff right here about just being consistent in your grading. That's all. So you can be very generous, or you can be very harsh, but just be consistent among different groups. And then I have this thing where I basically just want you to construct an SQL file just to help us so that I can put it into the evaluation database. So I mean, it'll all become clear as we go through, but that's kind of the idea behind how the projects are run. Are there any questions on the projects? I can't seem to access the projects link. Access to specific resources has been forbidden. Yeah, I need to update that. It's something with it has to do with Cambro when the sites copy over on Cambro. Let's see here. So what that means here is it means that this project regulations page, I need to update that. I'll do it during the break. And then I'll also include a link to a lot of the earlier projects in the course, so you can kind of see kind of what was acceptable before. That kind of might be helpful. All right. So that's that with projects. And then upload on left is where you can upload recitation work. So a lot of times, I mean, it's good for us to have you upload the recitation work. You don't. It won't be graded, but it will at least kind of be an evidence that you kind of did the work when you do the recitations. All right. So in the short exam at the very end, it will be short. It'll only be like an hour or an hour and a half or something. It'll basically just be simple variations on the earlier recitation problems. Okay. And then also content from the lectures and the slides and the handout. So it just, and when I say content from them, it just means that I want to, I might ask you for a definition of something, and then you have to kind of put that definition up. Now, the thing is that the way it works is that I don't. The exam is going to have to because of because of Zoom and everything, or because of the fact that you guys are going to be taking it on Cambro. It's going to be open book. So you're going to have the slides. You're going to have any resource you want in front of you during the test or exam. All right. Okay. All course material will be given in English. Recitations and projects. Maybe given either English or Swedish. And jag kan förstå svenska, så om du vill fråga mig på svenska, jag alltid gör det om du är mer bekvämt att prata svenska. Okay, so are there any questions about the overall? Actually, before any questions, let me just show you this little bit here on the site here a little bit more. What we have here is we have there's the overview calendar. I'm not going to be using this. It's just going to be, actually maybe remove it. Content here, this is what's important actually here. So down in here, you'll see here's all the content associated with the course. Now some of this is actually out of date and I'll clean it out, but basically what you have here, the important thing for now is the slides. So you have all the slides that are going to be coming up. I'll be adding 2 more lectures here on the data extraction and exchange. So that's going to, but all these are I might make small edits to these, but these are essentially set. Okay. So we're going to be going through those. So it's always a good idea to review these earlier, and then you can ask really hard questions of me and kind of, just really probe on the material and when I actually give the lecture. Okay. So there we are then. All right. Anything else on this site? I mean, I'll link everything through so that the recitations and everything. These are old recitations here right now, so they're not projects. What do we have for projects? So these are some projects from earlier, but I don't think you guys can access these quite yet. But I'll make it so that all these are accessible, so you can see all the projects over the last 3 years. I'm going to put that down as a projects earlier. Okay. Let's see then. So I think content. Right. This have to go. I'm not going to use the red book anymore. This was kind of nice. I used to have this, but now it's gonna boink. Gone. All right. So the grading. That's what we need. We didn't cover yet. So all right. So finally, the grading policy. So here's the grading policy. This course is divided into 2 moments. there's a principles moment, and then there's a practice moment. And both these moments are basically just going to be pass-fail. You're either going to get credit for them or you're not. And the principles moment has a maximum of 500 points, 4 recitations. Oh, I'm sorry. Correction. Let me go back to this. Now I realize I actually did have I kind of feel stupid that I didn't say this. So this is to response to Alexander. Are recitations mandatory to attend? Okay. So I think that later on, before I actually was kind of one of those things where that's okay. What I answered was true in the database, the initial database course, 202. But I got a little bit confused. I confused the two courses. And the actual truth is that they actually are mandatory in the following sense. That is, if you wanted to get credit for the practice, the principles portion of the course, then you're going to have to do the 4 recitations. Otherwise, because you need 250 points in both of in each of these parts to actually get a pass on them. So if you want those 4 ECTSs, those 4 European Credit Transfer System credits, then you need to do the recitations, or at least enough of the recitations to get to amass 250 points. All right. So the principles part is basically 100 points a piece for each recitation, and then 100 points for the exam or quiz at the end. So as you see, the quiz is actually kind of not that many points. All right. But you need to kind of show up for all this if you want to get a 5 in the course. All right. Now the practice side is essentially your projects. All right. So your projects constitute the practice part of the practice moment. And if with that is, generally speaking, you're going to pass the if you show up. So I think Woody Allen had this quote many years ago that said that 90% of life is showing up. And that's definitely true for the project. So if you go through the motions and you do it all, even if the project has really gone off the rails, most likely, if you just follow it all the way through, you present it, you do the video, you kind of do your best, you're most likely going to at least get 250 points. All right. But if you don't do that, if you chicken out because because the project crashed and burned, then you're not going to get the points, right? So you got to show up to get those points on the project. So that is 500 points for the projects. And then if you add these points totals together, then you get right here. This will be the overall grade for the course. So as you see, it's pretty tight when it comes to actually getting a 5 in the course. So you pretty much you're going to have to do pretty much everything. You have to do. It's not that easy to get a 5 in this course. A 4 or a 3 is probably not so hard. But to get a 5, you have to kind of check it. You have to kind of check everything off. And you do have to. And to this extent, to answer Alexander from earlier, yes, recitations are mandatory to this extent. All right. So is the grading policy clear for everybody? Is there one or many projects? Oh, there's just one. You just have one project. So with projects, it's just like you either team up with like 2 other people to get a group of 3, or you do it on your own. But you're just going to be one project at the very end that you're going to have. There are going to be 4 recitations, and there's going to be 1 project. Are there any questions? Okay. So what a recitation is, so I think that let me just go over this one more time here, because I think that for the students who haven't had me before, what a recitation is, it's the following. So let's just look at kind of an earlier recitation. This one won't be the recitation, but I'll show you an example of a recitation. I'm going to adapt this one. The first recitation is going to look a little bit like this, at least, but I'm going to adapt it. So let's look at this here. This is from last year, so this doesn't count, but this is how the recitation worked. It said, okay, for each question it's worth 9 points. So each one of these questions is worth 9 points, all right? And it's like, here's a database thing. I want you to kind of answer this SQL over that database. I want you to do an OLAP example. I want you to do a design problem, all right? So what this basically means then is it means that you're going to, on your own then, you're going to look at this thing, you're going to copy this thing, and you're going to do all these problems. You're going to do as many problems as you possibly can. Now, we're going to hold a recitation where it's going to be a 2-hour period. And before that, I want you to upload your results from this work onto Cambro. All right. It won't be graded, but I just want you to upload what you've worked on. And that also means that you can just write, if you want to work on paper, you can scratch it out on paper and then scan it. but I want it uploaded into Cambro. And then what I do is I just say, and then I want you to also make a claim and say, which problems can you do? Which problems do you want credit for? Okay? So you inform me of that, and I'll give you forms to do that in. And then what will happen is when we're actually holding the recitation, I will, let's, for instance, I'll come to the first problem and I say, okay. And then I would randomly pick one of the people who claim they can do the problem, and then I'll turn it over to them and say, okay, present your solution to the rest of us, right? Now, again, as I said, the point here is it's not that they do it perfectly. The point is that they show kind of what they do and what they were thinking, and they present it out. And then it generates a lot of discussion. In fact, a lot of times it's better that if the students do it wrong in an interesting way, because that generates more interesting discussion, right? So we discuss it and we go around. So it never happens, it never ever happens that a student basically just bluffs their way through and they claim a whole bunch of things they can do and then they can't answer the question. That never happens. But if it does, then you get put on a list, and then I kind of like, well, I'll call on you the next time. I mean, I'm kind of like saying, it never happens. I mean, I've never had students who are willfully trying to cheat the recitation system. But the whole principle behind recitations, and I'm sure that other people you've heard me talk about it's very, very, okay, there's this thing called the iceberg effect. And that is that when you do recitations, all we're seeing is the tip of the iceberg, all right? And that is the people who are presenting. But underneath that tip of the iceberg, there's an iceberg that's submerged in the ocean, which represents all the work, represents all the learning that happened to confront the problems. So that's kind of the principle behind these recitations from an educational theory point of view, kind of thing. All right? Now, does that clear up what a recitation is? Kind of how it's going to work? I mean, again, if you show up for these things, you'll kind of get the hang of kind of what's expected, and yeah. And the key thing is okay, good. All right, yeah, good. So that got cleared up. All righty. So let's see here. Now, where are we at? I think we're almost done here. So with this overview of the mechanics of the course, kind of took a bit of a time. Okay, so the grading policy. Yep, this is my email. You can always contact me there. Time edit. All right, I mean, I said there was something that they wanted me to post about COVID. I guess I sent an email out about that. So, yeah, there's that. All right, so I'll stop the share here, and then at least that one. Okay, now I guess you guys can see me again. All right. Let's see, should we just, yeah, let's just start in on the lecture here. So at least let's go a couple steps into this before we take a break. Or do people want to take like a short break right now? Do people want to take like a 5-minute break? We can probably just, I want to take a 5-minute break. I want a cup of coffee, actually. So maybe more than 5 minutes. I have to, one sec, I'll just be back. I got to start the stove here. All right. Could I ask everybody just to unmute and see what it's like for all of us to?
Okay.
Okay, I see all these unmutes going. I mean, I wonder if we're going to get any strange feedback in the system or something. Like once enough people unmute, if it's going to make a. Oh. Okay. Anyways, so I'm not really used to giving lectures on Zoom. So actually, I would prefer if people were unmuted. Although maybe you guys don't want that because if there's something strange in your. Okay, people are muting again.
Yeah, some people have buzzing mics. It can be annoying.
Yeah, I mean, maybe there's like kids around, or there's like friends around, or there's pets or something. I mean, that could be 1,001 things.
Yeah.
So I see people. Okay. I guess I'm just not going to get the normal lecture experience. I'm gonna have to live with that. That's life. Okay. All right, I guess just that email. I've got somebody here. All right. So I'm going to go back to this, and I'm going to. So I mean, does anybody who was willing to talk, have they had lecture on Zoom yet? One sec, I have to figure this out.
I did.
I'm sorry?
I did have a lecture on Zoom.
So what's your, do you have any kind of general, like what's good practice, what's bad practice, what's?
I don't know, I think you're doing just fine. Okay,
thank you. That's good. I needed a little bit of feedback there. Yeah, one sec here. I'm gonna just get to the slides here. Not that one, this one. Yeah, I mean, I guess one thing that it's like, normally what happens is that we have, here, one second. It's just like things like this right now with me dicking around here. I mean, that's not very professional. I mean, I guess one question is the issue of like breaks and like, I mean, normally, in a physical environment where you guys are all meeting together, it's kind of, there's a social aspect. So it's like during the, I would lecture until like the top of the hour, and then we'd take a 15-minute break, and then I'd come back and then and I could take questions in the meantime. So how do we simulate that in this case here? Maybe what we do is we go on break. The break doesn't have to be 15 minutes, does it? I mean, we can maybe be a little more time efficient here. Like what do people want? So let's say that normally what happens is we show up at 15 after. That's normal, right? So 10:15, and then
it would be nice with like 10 minutes, so you can just stand up and maybe pour some coffee or something.
Yeah, that's what I'm doing.
Yeah, I would like coffee as well.
Yeah,
just like 10 minutes or something, so that you don't have to sit through.
Yeah, exactly. So should we basically say that what we're going to do is, as a practice, well, let's still start at 15 after. Okay, why don't we do this? Why don't we say that what we'll do is we'll go to the top of the hour. Of course, right now, because of I have to kind of figure this out. We can, let's just say, okay, by the way, everybody, we're officially on break right now. So you don't have to be, you can go and get your coffee and all that now. So we're officially on break. But the idea is that what I'll do is we'll start at like 10:15. I'll lecture until 11. Then we'll take a 10-minute break. And then I'll lecture maybe to 11:55 or 12, whatever it might be. Does that sound like a good practice? We'll do it that way, right? Unless there's some objections. The flipped classroom. Yeah, I'm all for it. Interesting. There's some interesting comments here in the chat. So let's see here. Not to say there wasn't interesting comments before, but I mean, there are some interesting comments here about Zoom. This is my first lecture. Yeah, it's mine. When is the first recitation? Yeah, I'll get back to you on that. That will be announced later today. Okay. By the way, did everybody get my email about the COVID and like the Zoom thing? Did anybody not get my email? Oh yeah, I bet you didn't. So yeah,
I didn't.
Oh, you did get it.
Yeah, I didn't. Sorry, no, didn't.
Yeah, because I think that with you, I mean, probably because you're an exchange student, I think that you need to. It won't help for me to say contact student expedition. That never meant much to me. You have to. Do you know Ivan? Ivan? Yeah.
No, I don't. I don't know anybody in here.
Yeah. Well, don't worry, Jan. I mean, we're gonna get you in the course. We're gonna fix this. But it's just.
Yeah. Thank you.
The question is that is what I mean, to get you fully enrolled, registered, and all that, or registered. Then I guess you get put on the list. You were not on the roster. So there's the roster of the course, and I didn't see you there. So I think once you get it and put it in as a roster, then when the email goes out, it'll go to you as well. But for now,
Yeah.
I can just add you in because you send me email. I can add you in when I post it.
Maybe that's the reason I'm not on Cambro as well.
Yeah, I think so. Yeah, I think that you need to like somehow. There's something called Student Expedition. Does anybody have an email to them? Like who he should send a message to? Maybe you could post that in the chat. I think it's Student Expedition, but it's kind of weird spelling. I wouldn't. I don't really. And then you just tell them that you want to be registered in this course, and then just explain that you're an exchange student, etc. Yeah, look. So it looks like Jonas. He's put stud exp. Yeah, good. Okay. So yeah, so fire them an email. Yeah. Anyway, so I was going to read these other people their comments on Zoom. I had a whole course on Zoom. Yeah. Okay. I understand with the muted, but unmute. I want people to individually unmute here and there because. Yeah. Yes. So I would say that what people have to do is they have to come back at. We can run it like this now. So basically, this is going to be kind of a long break, but I think I need the long break this time. So we're going to be back at 11:10. So we'll always be back at 11:10. We're always going to stop at 11, and we're always going to be back at 11:10. All right. All right. First lecture on Zoom. That's mine too. Okay, so, oh, I'm sorry, that was a privately. Oh, sorry. Oops. About the flipped classroom. But I didn't say who it was, who said it. So flipped classroom. So I think okay, this idea of the flipped classroom has to do with letting the students kind of determine more of what the content is and what the direction of the discussion. And I'm all for it because I think that, I'm all for it unless it kind of, degenerates into something like we want to talk about, like Fortnite or something. Sorry. I think Fortnite's kind of cool myself. But anyways, we're not going to talk about Fortnite. No. So, yeah, so I'm definitely willing to let us kind of go in those kind of directions. I think the recitations in themselves are kind of flipped classroom-ish. And certainly the projects are, because the projects, again, you're going to determine what you want to do for the project. And then I approve it, of course. But if there's anything else about the flipped classroom that I'm missing there, the flipped classroom, I guess, just means the classroom gets flipped, which means that it's not like well, certainly this whole kind of model that you have this one authoritative figure, me. I think just me laughing like that probably undermines that authority. Yeah, I don't think that model works anymore in the world. That there's like some repository of all truth, and but I do have some experience, though, I would say. So I think maybe worth sharing. I think maybe. But flipping the classroom so that it's more democratic or more kind of bottom up and more kind of driven by more interactive. The students are more, it's more participatory. The old model of me just kind of droning on doing lecture. We're doing it in part because I have these slides, and I think I think there's some value in it, but I realize that just this pure lecturing methodology is really not working anymore. So, but I think a little bit of it. So 9 lectures. But that's why I want interruptions. Okay. Okay. Yeah, thanks for helping out with Jan here. If there's anybody else that is having a hard time registering for the course, just let me know. You can send me a private chat here if you want. All right. I hear the water's boiling, so I'm going to get my coffee. And again, we'll be back in exactly 10 minutes. Right? Okay. So I think we can now start on the first content lecture. If I need to, I will use this marker board here. I assume everybody can see that. But otherwise, what I'll do is I'll just present from the slides. Okay. So the slides in this course were developed over many years. I've edited them quite a bit. Steve Hegner was the person who originally developed the slides. The first thing we're going to do is we're just going to do a quick, in this next hour, we're going to do a review of relational databases in SQL, because we want to make sure that everybody's on. This is kind of going to be mostly a review for people, but just we want to freshen up people's SQL skills. All right, so the first thing to say, though, is, and I'll be making a lot of kind of side comments about this stuff. The thing is that we have, essentially, there's three different types of information systems. There's what are called information retrieval systems, and it's kind of funny, a funny name, information retrieval. It has a very specific technical meaning. What it basically is kind of like, well, it's just, the data itself is large bodies of information which are not formatted. It's just raw text, okay? Raw text, and this can be, this is kind of what the input is into Google. So like web search engines use information retrieval, and the queries are text searches. Okay. Typically, the model is just read only. All right. There's not updates. All right. Then we have database management systems, which is the primary focus of this course. And so you have a relatively small schema. So you have kind of a set of restricted set of tables that you're going to be accessing. And the data is fairly homogeneous in the sense that it's every data element is a tuple that conforms to that table definition, right? There's not much in terms of reasoning or deductive capability except for SQL, but there is an extensive formal update capacity, so you can do updates in a systematic way, and it's both read and write. So they're shared use, so you can have multiple users reading and writing to the database. Not so popular anymore is the idea of a knowledge-based system. So the idea of this is that you have a small body of heterogeneous information and then significant deductive capability. Usually it's in support of an intelligent application. So broadly conceived, actually, a lot of the neural models now are basically fitting into this. So you have this thing, it's drawing conclusions from the data it has, and there's usually it has a fairly diverse basis to it in terms of the data going in. All right, so when we talk about database systems, which is going to be the focus here, we're gonna delve into that. But the thing is that just one thing to keep in mind is that the information retrieval stuff will come back a little bit. We're going to touch on that a little bit when we talk about querying no structures, right? Later on in the course. Okay, so multi-user relational database systems. All right, so the open source systems, and this is the one that we're primarily going to be using in the course, is PostgreSQL. But we have lots of other different database systems. And these all conform to SQL and extend it in their own idiosyncratic ways, here and there. So the open source systems are the ones that might be mentioned in this course. Are going to be PostgreSQL, MySQL, and SQLite. So those are the ones that I work with, at least. Then the commercial databases, the big three is Oracle, DB2, and Microsoft SQL Server. All right, so we're not going to talk much about those, but it's good to keep those in mind. Those are the ones. Now, there's a lot of different other relational systems, and people might want to say this. So, has anybody ever used an SQL system that isn't one of these six? Just maybe post that to the chat if there's one. I mean, I can think of one, maybe like Access, Microsoft Access, maybe people have used. But there's a lot of different flavors out there. All right, so as I'm assuming everybody remembers, basically the relational model it's basically data stored as relations or tables. All right, so from the Silberschatz textbook, that's where this example is going to be drawn from. So the relation names are shown in blue. The attribute names are in lime background. The tuples are shown in bisque, and the primary keys are underlined. So if we look here, so this is kind of a database state here that we have. So how many tables do we have here? We have, well, we have the department table, we have the course table, prerequisites, classroom, students, instructors, advisor. All right, so this should look kind of, this should be understandable. So with this, you can basically do something like modeling a student being, let's see, student, oh, we don't have, oh, here we are. So a student is taking a course. So basically, student, Zhang is taking the course with the ID CS 101 in the fall of 2009. They got the grade of A. And this is the teaching record. So basically, you can represent this kind of university enrollment and grading database. This is kind of the example that we have. All right, so we're going to go with that example. So the schema. So when we talk about the schema, of course, we're essentially talking about the tables and their attributes. All right. So sometimes you'll hear people say something like this. It'll be like the signature, which basically means the table name and the attributes associated with that. So it's like the signature of department is department name, building, and budget. So in the case here of department, we have the department name is underlined here, so it's the primary key. All right. So there can be no two tuples in the database that have the same department name but are in a different building. Right. That's kind of what that's restricting that. So it's an integrity constraint. Right. So that should be fairly straightforward. So integrity constraints, like the primary key is the example, is the one that I just used a second ago. Those basically say that what they do. So if you look at this right here, if you just look at the signatures of the tables and you look at the fact, like the types, like so we have like string types, and maybe we have an integer type here. I mean, there's an infinite number of possible database states that could be filled in with this. But what an integrity constraint does is it kind of rules certain ones out. So we already, with this integrity constraint primary key, we're already ruling out department name computer science being in a building and then computer science being in a different building. That's being ruled out. So the primary key is basically saying you can't have that as a possible state of the database. So that's what an integrity constraint does. It kind of it shaves down the possible set of states of the database. Foreign keys are another type of integrity constraint. So what foreign keys basically are saying is they're saying that things have to kind of make what's called referential integrity. So referential integrity basically means, like, so we have something like this. We'd say that if I'm going to have an instructor in the database and then I'm going to give them a department name, then that department had actually better be in the database as well. So if I say, the ID of some, instructor and then the name of the department is like basket weaving, but there is no basket weaving department, then it will block inserting that tuple in the first place. All right. So that again restricts the number of possible states of the database, and this referential integrity is extremely important to have in databases because otherwise you can have really junk states to the database that are really hard to recover, really hard to understand what was intended, that kind of thing. All right, so this right here is showing the these foreign key, basically these foreign key referential integrity constraints. The dash line, we're not going to get into this dash line so much, but sometimes what you have to have is you have to have something that is kind of like, so this right here says a time slot ID. The fact is the time slot ID here is not a primary key of this, but you can still have it where the time slot ID has to be represented in that table, right? So there's something actually that's more general than integrity, than a foreign key constraint. It's called just basically an inclusion dependency in theory. And it basically just simply says that if you did a projection on the slot IDs and got a set of items here, and you did a projection on time slot ID, that this has to be a subset. Whatever it was generated here, it has to be a subset of that. But if you, technically speaking, it's not a foreign key because this time slot ID is not a key of that table. Right? How you specify this in SQL becomes an issue later. You can't do it with references. You can't do it with a foreign key definition. You can do it with triggers instead. All right, then there's something that always kind of causes some difficulty, and that is this special null value. So the semantics of null is not specified, but it is a value, so it's a value that the database can get, and that attribute values can get in a tuple. It can have different meanings. Essentially, these three meanings are kind of the primary ones, although there are people who will argue there are many more different types of meanings. Let's just kind of stick to these. So when you see a null value in a database, it might mean the value is not known. All right. So for instance, one example might be an email. So you have this kind of marketing database, and then we have an email, and we have a person, a potential contact, and we have a null value for the email. But what we mean, what we're actually intending to mean by that is to say that they probably have an email, but we just don't know what it is. So the value is unknown. Now, if you look at telephone, it might be a little different. So, or let's say landline telephone. So in that case, what null might actually mean is it might mean that, well, they just they don't have a telephone. So null is basically saying you don't have one. So like if I had something like I had something like pet name, right? And then if I don't have a pet, then that would be null, which would indicate that there is no pet, rather than we don't know what the pet is, right? There's a sort of slight kind of difference in semantics there. Another one might be something like an inappropriate attribute. We usually get this when we start having is hierarchies, but it might be something like saying that that by definition of their role or by definition of that particular tuple, it doesn't apply. All right. So for instance, if we had personnel, or we had people working at a place and some people were volunteer, then the salary value for them would be null, but it would not be because we didn't know it, and it wouldn't be because essentially in this case it would be because it's the inappropriate attribute for that person, right? So it gets a little bit, there's lots of different meanings, but it's these are kind of the three primaries, although we can argue about that in particular cases. All right. So what does the null value for the grade in the takes relation of the university student mean? Okay. So we can think about that. What would it mean to have? So it might be that it's not assigned yet. It might be that it won't be assigned. It might mean that it doesn't apply. So they might be taking the course as pass fail or something, or they might be just sitting in on the course. There could be lots of different meanings. All right. So what we just covered there is just the idea of integrity constraints, and we just kind of covered quickly the idea of how null values may creep into these relations and kind of what they might mean. All right, so now we're just going to go on to the SQL standard. So let's just we want to do this fairly quickly because I'm assuming that again, I mean, any message in the chat. If you have any questions, please put them in the chat. All right, so SQL is a standard language for database, access to relational databases. So there's kind of, there's a long history of this. The most influential, I suppose, standardization of it was 1992. That's when kind of a lot of the vendors really did start conforming. SQL itself comes out of work that happened at IBM back in the 70s when the relational model was first introduced, and it was more designed by programmers than it was designed by maybe researchers or theoreticians. SQL kind of gets a bad rap a lot of times because it's kind of a grubby language. But the fact is, though, is it does quite a bit, and it's higher order. So I mean, if one wanted to kind of stick with just being a theoretician, it would be very difficult to deal with stuff like counting and kind of aggregation and keep it kind of a nice, clean, formal language. SQL took a lot of, SQL definitely has meaning. It has but it's kind of, it's not really semantically well founded in the theoretical sense. So and they were kind of in a rush to kind of get the syntax to support users' needs. So it's much more based on practicality, but it's pretty much withstood withstood time. So it remained the dominant database language. In fact, almost the only database language until we get to this NoSQL movement, which we'll talk about later in the course. It's gone through a lot of iterations, but basically the idea is that there's kind of a core of it that everybody adheres to, but then there's lots of vendor-specific extensions. Okay, so it's got it's kind of big in that. So most implements a superset of a subset of the standard. Yeah. So there's the standard is like this, a huge number of it's a very large document or set of documents, and there's an industry group that decides it or defines it. But anyways, in this course here, we're going to stick to the PostgreSQL standard. So if you had an application you wrote in PostgreSQL and then you wanted to port it to like MySQL, you wanted to port it to Oracle or something, then you would have to make some small changes, but essentially it's going to be the same SQL, as long as you don't use too many esoteric things inside of PostgreSQL. But it's portable with effort. So the parts of SQL. So there's kind of this. So these are all kind of large documents that kind of get the definition of it. But we have what's called the DDL. So that's the data definition language. So this is this is like the create table kind of statements. That's stuff where you actually define the database. And the DML is the thing with like the select statements and the update and delete and so the things that actually kind of manipulate the data, not the actual table definitions. All right, transactions is a set of SQL commands that are there. This gets kind of vendor specific, but that are there to kind of control concurrent use of the database. So when you have multiple users going into the database, so they all pretty much have like begin and commit and abort. But then there's the way they specify which isolation levels and this kind of stuff is sometimes different between the different vendors. But there's a SQL. There's a lot of specification on how transactions are defined, and we're going to have a whole section of the course on that. Authorization is likewise. This is something that it's like when you grant different privileges to different users. So you have users and you have privileges that you're granting to them to access the database. That's part of the SQL standard. That's kind of a separate document within it. Then there's a whole bunch of this different stuff, which we're not going to kind of touch on so much, but that's this business of how you access SQL from a host language. ODBC, this Microsoft standard, has been very influential, but it has to do with kind of what are some of the standard libraries and cursors. How do you actually get into the how you actually have it so that applications talk to the database. Okay. All right, so defining table. So I think that you guys have probably seen this this kind of thing before. So create table. Let's see. Again, questions. Any questions you have? This is again back to the university example. So we create a department. This is how we actually create the table, right? So it's kind of got an old-fashioned syntax here. So department name varchar 20. So what you'll see here a lot of times, at least what I do now, I try to make it a little bit more modern. I don't really use varchar. I use text instead. So PostgreSQL will let you. Most of them will let you use the text instead of varchar. So that's kind of a bit more of a modern way of specifying it. But you get a lot of control over varchar. So basically, you're saying how big the maximum size of the field is. So if you have a really, really large database, it's actually important to use varchar so you can make it a bit more space efficient. We have it right here. This is also an integrity constraint that can be brought into SQL where you check to make sure the budget is positive here. All right. So that will rule out states of the database where the budget is negative. Right. So that's the kind of the idea there. Not null. So again, you're specifying certain legal states of the database here with these kind of declarations. All right, then you have this issue of like how it deals with in the foreign key. What would happen if you delete? So what would happen? Whatever you're pointing to. If I delete the department here, if I'm deleting the department, what do I do? Well, what I do here is then on delete I set it to null. So then this would become a null value. All right. So there's another example of a null being used in a different kind of meaning. So that would give you some behavior that would happen. What else do we have to say about this kind of stuff? Again, this is PostgreSQL, so you have you can name these things here, and then you can turn them off later, right? Update a cascade here, so that's a little bit different than set null. That has to do with just like whatever value. So if you're referencing the student ID, the ident here, the obligatory exercise here, the ident is pointing to a student, but if that student's ID changes for some reason, then that would cascade it down to the tuple here where it was recorded for that student. Adding constraints. So there's a whole, this is again part of the data manipulation, I'm sorry, the data definition language where you can alter the constraints. So you go in and you can alter the table and you can add constraints. You can alter tables also and do things like change the attributes. So this alter stuff, you'll find yourself using this stuff in practice because sometimes the database signature or the table signature has to change. And you don't want to do something like rebuilding the complete database, and that's crazy. So you'll go in and you'll do stuff like altering it. Okay, so for instance, you might need to add a very common thing is you need to add a column to a database table. So you do that via alter. Right. Okay, so that took care of the kind of the data definition language, us going and specifying kind of the structure of the database. Now, if you talk about SQL, then SQL, the data manipulation side of it, so we're actually getting, we're actually going to be getting results from the database. Oh, an SQL query, basically, this is a select query, so this is a read query, follows the form of select set of attributes usually, and then a set of set of tables, and then conditions. All right. So this is kind of the basic template of an SQL query. So to take a very simple, the simplest query possible here would be, or a very simple query, would be something where you are doing selecting the name and the salary for instructors. Okay, this is just a projection if we want to relate it to relational algebra of name and salary from instructor. The star syntax, what that's doing is it's basically going to get all the attributes, right? So select star from instructor will give us the full table with all the different attributes. Here we're actually going to have a where condition. So the name and salary from instructor, where the department name is computer science, right? So I assume this is all fairly clear. Yeah, so if we want to rename the columns to come out, so it's like it relates to the relational algebra. The idea that behind SQL, it doesn't conform to this completely, but it's what it's supposed to yield is a table from or a relation. So when I say table or relation, they're synonymous. Usually more in the SQL side, you say table, but when you talk about more theoretically, say relation. In this case here, what you're doing is you're kind of generating a new table or relation in the SQL query. Let's say relation in this case. And you're giving it new attribute names. You're getting it new Nachman and Gehalt, so it's a German. You're doing a German version of the table. All right, so this is, I shouldn't say a table comes out of this because what's coming out of this is just an answer result, but this could potentially be fed into a table. All right, the names will appear as the column headers, yeah. Okay, so, however, such name changes cannot be used as aliases in the where clause. All right, so this is actually happening, you have to kind of think about where it's happening. It's happening after it's getting evaluated, it's doing the renaming then. So you can't use the names down here in the where clause. It wouldn't know about them quite yet. So this thing is good. This whole block here is going to generate a relation, and when it finally generates that relation, it'll give them these new headings. But you can't use those headings inside the conditions as you're generating. Okay, so that's kind of an explanation as to why you can't do that. All right. So likewise, the as can be reused in the from clause. We'll see maybe an example of that. Maybe not. All right, so you could say something like from instructor as X. Now, if you do it there, then that name can then be used down here. You could say X dot Gehalt, or I'm sorry, X dot name or X dot salary. Okay, so duplicates in order. So yeah, so typically the SQL is bag semantics, so duplicates are not removed. If you use the distinct keyword, then they do get removed. So it's always something to kind of keep in mind there, is that set semantics versus bag semantics. Set semantics are kind of the logical way of looking at things, so there are no duplicates, and bag semantics is kind of how it gets implemented in practice. And we'll see some good reasons why they use a bag semantics. It's more efficient. Distinct will then give you the set semantics, so it'll remove the duplicates. All right. Now, here we're doing ordering by. So salary descending order, salary ascending order. Here, yeah, order by. So the order by can actually have more than one attribute. So it can just, you can do the lexicographical order using multiple attributes. So the name is primary. It's the first one you sort by, and the second one, if two names are the same, then you'll go to salary as a sort. If the names and salary is the same, then ID becomes what determines the ordering. Right, queries and two relations. Okay, so this is kind of where, this is the idea of joins. So this is kind of, I mean, you guys all know this, but I mean, we're just going to cover it for the sake of completeness. I mean, joining is kind of where a lot of times people will get confused if they don't know SQL very well. So what we have here is so really to kind of do any kind of complicated querying, especially over this database example we have here, you're gonna have to be able to do joins. So if you want to say something like, all right, so if you do this right here, you say select building and name from department instructor, this will generate something, but it won't be conditioning the join. So it'll basically give us as a Cartesian product. Okay, so it'll do all the possible pairings. But if you put in the following here, so you say, give me the buildings. So what we're looking for here is we're looking for the buildings and the names of the instructors. So this would be like, the instructors that are associated with what building, and they're doing it through a department, because the instructor is in a department and the department is in a building, right? So what this is basically saying that is it's saying that this is the correct answer here. What it's saying is that we're going to look at both these tables. We're going to look at department and instructor, and we're going to join them. Okay, so we're going to join them on the department name, so that when we have an instructor that's in, say, computer science, then we're going to pair that with the department computer science, right, which has the name computer science. And so its department name is computer science, and the instructor is computer science. And that right there, when that condition holds, then we're going to print out the building and the name. All right. So that's how the join works. So if you just do it this way, you'll just get all the possible pairings. So if there's a building for the chemistry department, but I'm in computer science, I'll still make it through here as a possible match in the Cartesian product. And so that will print out the chemistry department's building and then my name, which is not really meaningful. But in this case here with the join there, then only Meet Huset, where the computer science department is located, will be associated with my name. All right. All right. So the join operation, a lot of times what you'll see that you put the join operator inside the from clause. All right. And so a lot of times what this will do is so this is what's called a theta join, if you recall from relational algebra. And what it's doing is basically specifying which attribute to do the join on. It's equivalent to this. So these two are equivalent. This query here and this query here are equivalent. Just a note, though, that is that this one up here is a lot of times better because it gives the query optimizer more of a chance to recognize and to see the join. All right. So a lot of times what you'll find that putting things in the from clause here and then having these join directives will, in many cases, I mean, it's kind of, you don't know, it depends on the implementation, but a lot of times it'll speed things up because it'll give the optimizer a bit more instruction. Yeah, inner. There's a difference between inner and outer join. All right. So this right here, yeah. So this could also be like getting these where the salary is greater than a certain amount. The building and instructor names. All right, so natural join is also got its a keyword. So natural join basically just means that when there are attributes that have the same name, you'll force equality on those. They have to have the same name and type, of course. You'll force equality of those when you're doing when the join is being calculated. So in this case, you put the department name that works. All right. So it's a little bit different because of the matching columns. So here you're going to have matching columns. You're going to have department name duplicated in the result that comes out of this. But in this case, because of the natural join, it recognizes them as the same name and type. It will basically just coalesce them into one attribute. Right? All right. Yeah, alias and self joins. So what are we looking at here? So when you do a self join, you need to have aliases because otherwise it becomes ambiguous as to what you're referring to. So what that means here is that if you're going to basically say, give me all the departments, we want to get the departments that share the same building. That's going to require self-join on the department table. So for us to do that, what we need to have like D1 and SD2 so that we can separate them. We know what we're talking about, right? And then when we do the join, we can say the building is equal to D1 building is equal to D2 building, all right? So when you do self-joins, you need to have aliases, right? Theta joins, yeah, so I think we already essentially covered that. All right, so now we're looking at the, so queries, again, in SQL, the standard, they return bags, they don't return sets. So bags allow for duplicates inside them, okay? So the set operations also apply to, the bags, but they have a little bit of a different semantics. So we have this union, intersection, and difference. So what'll happen with unions is that when you union two bags together, you'll get more duplicates, right? Intersection, it'll actually kind of do kind of a sophisticated counting, whatever has the least. So if you have like 3 duplicates of A in one set and 4 duplicates in the other, the intersection will return 3, right? And then same with difference. It's kind of if you have 4 and 3, then 4 minus the one with 3 in it will be 1 with 1 in it. Okay, so it's bags are a little bit more complicated than sets. All right, embedded subqueries. So embedded subqueries is that what we have here is we have a spot now where we can just substitute an SQL query in to get a value. So this right here, a lot of times you don't want to do this. There's a lot of problems with this actually, with doing this, but SQL lets you do it. So right here, let's look at this right here, this subquery here. So we're saying like department name equals, and then we're gonna get the department name of this particular individual. Okay, so this will work. So it'll yield. I mean, it's doing a little bit of kind of clobbering. It's doing a little bit of interpretation here because it's promoting a singleton set. If this can come back a singleton set, like the department name, let's say that this person is in computer science, it'll come back strictly speaking as a singleton table with the attribute computer science, but somehow that gets munged into just computer science as a value, all right? So it does that though. But let's say, for instance, we had the name Smith here, and then it yielded 3 different departments. Okay, that would yield a runtime error. So this is not the cleanest aspect of you have to be a little careful with SQL when you do this kind of stuff. So you have in here something that most of the time would work, and then at runtime would give you a value, but then if it happens to be a name like Smith and you get multiple departments, it might crash it, okay? So not such a great thing. You can do in, that's maybe a little cleaner, all right? It's maybe a little bit cleaner, it's gonna be, but that's just these subqueries, that is cleaner, yeah. So that'll be prone, that won't be, Smith won't cause any problem there, but it will return multiple instructors from different departments. Okay, all right. So then we have the exists subquery. So where we're saying something like, you can have this in here, here's where we're getting the course IDs that are being taught by this particular instructor here. Let's see here, what do we have? Find the instructors who teach or have taught a section of a course, which Srinivasan has also taught. All right. So this right here grabs Srinivasan as the ID of Srinivasan, and this is the course ID is in something that has been, the teachers has been taught by them, and then we have the set here, course ID in that'll give us the courses that happens, and then we're going to pluck out the instructors. Okay, I think there's probably better ways of doing this. You can exclude it here. Yeah, anyways, I think that it's this is not really existential quantification. There's no exists in there, so we'll kind of get to that. Let's see. I think we're gonna get one that has an exists. We covered this quite a bit in the basic database course, but let's see what we have here. So maybe the best idea is just to kind of go through here and just make sure that you can track along and understand how these queries operate. I mean, it's they're all correct. They all execute and they perform over PostgreSQL. Let's see here. Yeah, so you're just showing that you can do intersections here, and it's kind of showing realizing except using subqueries. Okay, find instructors who've taught or have taught none. All right. Okay. So I think this is an example of where so SQL has exists, but it doesn't have a universal. So you get universal with with embedded not exists. Okay, so this is kind of this division operator. Maybe I can, if I get time in the lecture, we can come back and we can do an example on the whiteboard. But I think that we kind of dealt with this in the earlier course, so I think maybe a lot of you are going to get it. But let's just say for this, just to kind of put something out there. Find the instructors who have taught every course which Srini has also taught. So that's equivalent to give me all the instructors for which there does not exist a course where there does not exist a record of Srini Vasan teaching. All right, so that's kind of the double. You can have a double negation of existential. Will give you a universal. So if I want all the instructors who have taught let's say all the instructors who have taught every course, let's take that, then that's equivalent to give me the instructors for which there does not exist a course for which they have not taught. All right, so this doesn't come up so often, but it's kind of nice to know the double not exists gives you a universal. All right. You can also do this with aggregation, which is probably going to be better. All right, these I don't, in practice, I don't commonly use the all or any, but they're there in SQL, and it's just kind of going to be ranging over. So it's not a universal for all, but basically it's saying, give me all these. So this is the one with the highest salary. That is like, give me the instructors where the salary is greater than or equal to. You can't have greater than. If you just have greater than, there'll be nobody. Where we take all the salaries from instructors. So there's going to be greater than all of those. And then likewise with any. So this is the one with the lowest is the only one who would not qualify here. You typically are not going to be using these. So I would just in general say, try to avoid the all and any. I mean, but they exist there. Okay, so now let's get to aggregate operators. Let's see, what time are we looking at here? All right. We're just going to go to the end of the hour here. Try to get this completely done if possible. For each department, find the minimum, maximum, and average salary as well as the number of employees. All right. So what you have to do here for aggregate operators, of course, is they have to be grouped on something. They have to, and then this is being grouped on department name. So it's for each department. Now we're going to have basically a set of employees for each department, and over that set, we can actually compute these aggregate functions. And this aggregate function, so aggregate function always takes a set in and gives you a single value out. So minimum, so when I say minimum, so it's taking the set of salaries in, grouped by department. So one particular department, we're going to get all the salaries coming in there, and it's going to calculate minimum of that. So that's going to just generate one result. That is, that it always requires a grouping. So I think that most of you, you'll refresh on, in the recitations, you're going to refresh on this anyways, because we'll be given these kind of things. If you omit so this right here, if you omit this, then it's going to group on everything, right? So it's it's going to basically take all the classes, all the what table is all the instructors here, okay? This right here, of course, won't work. So this is the one where it's kind of the gotcha. It's because this is meaningless now because you need to group on department. All right, the having. So the having, basically what it does is it does the following does not work. Okay, that doesn't work, but this is the one where what we can do is we can basically say Once we actually calculate the results from the aggregation, then we can apply the condition having on that. So this is basically going to be, so what we say here, what we're looking for here is we're saying find at least the departments with at least 2 instructors, and then give the minimum, maximum, average salary as well as the number of employees. So this doesn't work because what it's doing here is it's calculating this first, and it doesn't like it simply doesn't like this the where, because the where actually should be going over single tuples, not over the aggregate, not over the aggregate function values. So you can put this outside here, and this one then basically is talking about the groupings. So it's going to put the condition of count on the groupings, right? So there's a subtle difference there, but it basically shows that in this case here, you need to have to get this kind of logic. You need to have having. Now you can actually always rewrite a query so that it's not using having, but the problem with that is it becomes very inefficient. All right, so I can have a query where a subquery calculates the table with the counts and all that in it, and then I can have a where condition over the result of that. But the point is, you want to have having, because when you get to these kind of complicated aggregation type queries, inserting the having in there lets the optimizer go in and do it right. Okay, do it right means that they can do it in fewer passes, and if you have a giant database, you can do it much more efficiently. You make a big difference. Okay, so having is definitely legitimate, even though it could be rewritten. Right. Same is true, of course, with something like outer join. You could always rewrite outer join as just kind of elementary, unions and kind of more elementary operators. But you wouldn't want to do that, because when you have outer join, then the optimizer can take advantage of it. All right. So pattern matching. Okay, so now we get into stuff like some of the things that you can do inside of SQL that are just kind of like little syntactic sugar on there, in there. Or I mean, they're legitimate. There are different operators you can do that will do stuff. Okay, so in this case here, the like is something like where it'll do a partial match or pattern match. So if you want somebody who has like the name that starts with the letter C, you put this in there. Now, one thing we're going to cover later in the course so this is really, really not nice. I mean, similar to, yeah. So we're getting here now, we're getting into some type of something that's looking more like regex. Okay, so we want to actually look at the regex. Regular expressions are really powerful, and we're going to be looking at regular expressions later in the course. I mean, I think a lot of you probably have done stuff with regular expressions before, but it's nice to kind of go through them systematically. So what we really want is we want to have something using regular expressions inside of SQL, rather than this old-fashioned like thing. That's just kind of a matching. But regular expressions are a much more general way to do stuff. All right, so you can just you can put the conditions in here. All right, so then let's just kind of quickly. Good, I think we're making good time here. At least I think so. Just to kind of cover all of SQL first. Yeah, let's keep on going. So, inside of this is still part of the data manipulation language. What we have here is we have ways to make changes to the database. We have insert, delete, and modify. This is called the IDM model of database updates. So this corresponds to the insert, delete, and the update operations inside of SQL. So insert, you see this insert. You can just have the tuple there. You insert. And then with the values, so here comes this new instructor. And if there's any failure of the integrity constraints here, so for instance, if there was a, looks like we don't have in here any, putting null in here for the department. Anything, if you put department in here that didn't exist, it would then fail at the insert time. Right, so it's doing the integrity checking then. Delete works as, kind of like, well, you go over a table and you specify a condition. You can be a little careful with this one. Delete, and then we have the update set. So update a table, and then you set some attribute to equal to a value where a certain condition is met. Again, you have to be somewhat careful with that one. All right. It's always checking the integrity constraints. unless you defer them in a bulk operation, it's checking those to make sure that you don't put the database into an illegal state. All right. So this right here is this way you defer it. So multiple updates, integrity constraints. So you can, let's see here, what do we have? Oh, this is just an example of the, so if you defer it through explicit transactions, you can do bulk operations where you temporarily put it into a bad state, but then you patch it up and you fix it so that it's in the right state, because you might have some chicken and egg problem with kind of circular referential integrity, circular foreign keys. And you can do all the operations, and then you can basically put everything into a right state and then end the transaction, and then it does an update to the database without. So in those intermediate states, it's violating the integrity, but then by the time it's done, integrity is maintained, and then you commit the transaction and everything gets done. Right? Okay. All right, so let's see here. So cascading updates. So this has to do with those things that's specified in the create table. These are things that a lot of these things you just kind of you get a feeling for these things kind of just in practice. Let's see here. Okay, it looks like the final thing we're going to talk about here is outer joins. I know I referred to these earlier, but outer joins are quite often. This comes up quite a bit in practice. In many cases, you have outer joins. A lot of times outer joins come because what you do is you're bringing in. So when you're building, a lot of times when you're building databases, there's lots of different possible associated with one particular tuple. Let's say that we're trying to scrape something, and we have a company, and then we might have the location of the company, we might have the some other statistics on the company. In some cases, what we have is we have companies that don't have any location information, but they have the statistics information, or they have some filing information. And what outer joins will do is they'll just kind of present everything as a giant table padded with nulls. And yet another example of nulls coming in a different meaning. Maybe that'll make more sense later when we talk about, so a lot of times what you do is you'll be getting different types of tuples, different types of tables be filled in on a particular object. And some objects have missing information. So outer joins, a lot of times, will just kind of bring everything together. If you do an inner join, then you're going to get, the only ones that are going to come in are going to be the ones that all the data, the elements that have tuples in each table for, right? Because if it doesn't inner join, outer joins will at least kind of pad out nulls. So it comes up very, very often, outer joins. I'm just trying to say in practice. So let's say, well, what is an outer join? Let's get that clear. So what an outer join is, it basically does a join, but then if there's no match, if it doesn't match on the join condition, it'll pad with nulls. All right. So let's see if we can get a good example here of outer join here. So left outer join. What this says right here, it says that we're going to basically we're going to get the ident from student. Okay, and left outer join that with the recitation where the number is 1. So what this means is that if a student doesn't have information, so we have a student ID, but they haven't done recitation number 1, then we'll still get their ident. We'll just have a null value for their score. Okay, right outer join is analogous, and then full outer join, which is a lot of times what you'll see, that would be something where if there's like a record of somebody getting a grade on a recitation, but the ident is not in student, then basically it'll give you that grade, and then it'll have null for the ident. All right, views. Okay, so views are kind of virtual tables that you define. So if we create the view instructor student, this right here is creating a view that basically matches the instructors to students that they've had in their courses. And so what it's doing is basically saying, it's finding, well, for each of the instructors, is there a way to join it with the teaching of the course that a student took? And then it presents that as the instructor ID, the instructor name, the student ID, and the student name. So it's pulling out the instructor IDs and their names and the students and their names where the student has taken a course that that instructor taught, okay? And this, when you define a view like this, now if you want to say, well, let's get a record of the the instructors matched with students or something, what it'll do is it'll unfold this at runtime and turn this into this SQL query here. So all these are done virtually. It's quite elegant that the way views are done. But only under limited circumstances can you update a view. So if you try to update this view, you say, well, there's a particular student that we know of and a particular instructor, and we know that that student has taken a course of that instructor. Let's insert that as a tuple into this view. Then there's an infinite number of ways of reflecting that back to the base relations. It could be, what course was it? You know, it's ambiguous. So that would be prevented, all right? In some cases, you can do updates to views, but it has to be an obvious way. There has to be an obvious way to reflect it back to the round tables. PostgreSQL does actually support some updates to views. All right, so now let's just, I think we're almost done here. How much time do we have? I think I just want to finish this. Sorry, it's going over a little bit, but we're going to get SQL kind of covered here. So we have the logic of null values. Again, null values basically cause us to go into a 3-value logic that's basically true, false, or unknown. And if you say something like, we say A and B, if A is true and B is unknown, what would A or B be? Well, they'd be true if you think it through. But then if you say A and B, they're let's say they're unknown and false, and we want to say and, or sorry, unknown and true, we want to say and, then that would be unknown, right? So this is kind of the truth table, logic table that gets yielded with null values. And this can cause some problems. So for instance, if you say something like, give me the students who have, if you have a null value for a grade and you say, give me the students with a grade over 3, or a student with a grade 3 or less, logically you would think that every student would apply even if it's null. But in this case, that would be unknown or unknown, which is unknown. And the where clause will only let tuples through when they're true, okay? So anything that evaluates to unknown in the where clause will not be included in the answer. All right, so this is just, these are some kind of examples. They come up sometimes. There's an old saying that says any null value in a database makes the database meaningless. But that's coming from more of a research background. So null values can be a little difficult here. Let's see, from Libkin, yeah, so consider these, if you can just consider these cases here, you can see that, that it's gonna give false positives. You can get false positives, you get false negatives. It undermines the logic of databases, but these are usually constructed examples. You just have to be a little careful when you deal with null values. All right, okay, so that was a whirlwind tour of SQL, and I hope that people got some value of that. Anyways, you'll review this. I mean, you'll get a chance to either review these slides or to review this. You know, this will become applicable when you do the recitation 1, because there's going to be some basic SQL in recitation 1. And then we're going to, next lecture, we're going to do more advanced SQL, so stuff that you probably haven't seen before. I'm assuming all the stuff that we covered today you've seen before in one way or another. But if you haven't, definitely brush up on what was covered. So this is just kind of, the course assumes this knowledge, right, that you guys all understand. Okay? Are there any reading? Okay, good. Now I'm finally getting some questions here. Okay, are there any reading instructions or similar? So I would just suggest that wait for recitation 1 when that comes out, and then you print these slides and go back and look at these slides to kind of get the understanding of. Well, you might want to look at these. Don't print these slides out. Don't print anything. Just look at them, and it'll give you pointers on how to solve that SQL. You can also look on the web and stuff like that. As for like reading, like reading from the textbook, no, there's not any reading assigned except for the slides. So you're kind of responsible for what's on the slides for the quiz later on, but there's not going to be like readings from the textbook assigned. Yes, it's the same book. So it kind of is derived from that, but it's not, again, it's it's there as a reference. It's not there as we're not going to give you readings out of the book. I mean, if you didn't take the database course earlier, don't go out and buy that book. I mean, you don't. The slides are most of your ground truth here. Well, I do apologize going over a bit, but we got it done at least. Yes, I'm supposed to say that you're not. That's illegal. You're not supposed to take free. It's that would be against the rules. Oh, so there was yeah. I saw. Actually, I saw that too. I'm sorry about that. This is somebody who's open the. I saw that 12 there hanging off the end of the thing, and I was a bit confused too. I was like, wait, no, I thought it started at 10, and then I looked up and I saw it was at 10. So that's kind of a bummer. But yeah. I mean, the slides. I mean, just let me know if you have any questions, Michael, about anything. I mean, but definitely review the course content, the Cambro. Yeah, I'm going to do the recording, but I have to kind of look around for that. I'm a little bit worried about it because the spot it was supposed to be on my Linux system. I snooped around and I couldn't find it, and so I mean, I'm recording this. I should probably tell people that. And I'll try to make it available. Although the thing is, I don't know. I really don't like being recorded. I mean, but yeah. I'll look around. I'll try to see if I can find it somewhere. I did try to record it, but it at least it wasn't in the standard place. But maybe I'll edit a little bit to kind of get rid of all the ums and the uhs and the wasted time. Yes, 10 means 10:15. Yes. I mean, it's a little bit anachronistic in the Zoom time, but that's kind of what we do. I think it all comes from like some bell, when a bell rings, you have 15 minutes to get somewhere. It's just kind of silly. It's back before people had watches or something. I don't know. So yes, everything starts at 10:15, and then we run to 11, and then we're going to just take a 10-minute break, and then we're going to go from 11:10 to 11:55. Although it looks like today we went longer. So. Maybe I should. Let's see here. Exit, stop share. I should have done that a while ago. Okay. So now it's probably back to me. So, okay, everybody. Unless there's more questions, then let's meet again then on Friday, I guess, at 10:15. Same Zoom channel. So, see ya.
Bye.
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 Bye.